this video, I'm going to talk about ice tables. An ice table is a problem-solving method or strategy used to determine what the concentrations will be once equilibrium has been reached, meaning that it helps you find out the concentrations of products and reactants at equilibrium. Ice tables are also commonly called rice tables because of the addition of one more factor to the chart. So ICE or RICE stands for reaction, initial concentration, change, and equilibrium. Now, if you go with the ICE method, that's what you're used to, you can just omit the R part. But that is basically just a little bit more organization. So R stands for reaction, meaning you simply just write the reaction, the reactants and the products. I stands for initial concentration, that is the initial concentration of the reactants and products as well. C stands for change, and E stands for equilibrium, which is just the final concentrations, or the concentrations of the products and reactants at equilibrium. For C, it's good to know that if the system proceeds to form products, the amount of products will increase and the amount of reactants will decrease by nx, and if the system proceeds to form reactants, the amount of products will decrease by nx and the amount of reactants will increase by nx, in which n stands for coefficient. So that will vary depending on the coefficient of each product and each reactant. Now let's solve a problem using an ice table. Okay, so we have this reaction and we're asked to find the equilibrium concentrations for the following conditions. So our reaction is hydrogen gas reacts with iodine gas to form 2 of hydrogen iodide in gas form, and we have that the concentration for hydrogen and iodine, which are the same, are 0.0432 molar, and for hydrogen iodide that is 0.00703 molar. Given that our K constant is 4.76 times 10 to the negative 4 and Q is 0.0265. So really half the work is already done. We know the values of K and Q, so we can tell where equilibrium is going to proceed, and that should be the first step. So in this case, Q is bigger than K, meaning that the system is product heavy. So it needs to proceed towards reactants to reach equilibrium. More reactants have to be formed. Now this will help us on determining how the change will proceed, because the system is proceeding towards reactants, is going to form more reactants, meaning that the change will be positive for the reactants and negative for the products. So now let's solve our ice table. So first we had R, which stands for reaction, then I, initial concentration, C, change, and E, equilibrium. So for R, we simply write our reaction. We had hydrogen gas, that is our first reactant, plus iodine gas, second reactant, is at equilibrium with 2 hydrogen iodides, another gas. And really this is just the difference between rice and ice. People just omit the R and just write the reaction without considering it as part of the chart, but it's really just the same thing. Now we can consider each different. So we have this reactant, and finally our product. Everything is going to be different for each. So I stood up for initial concentration, which is, for the case of hydrogen, 0.0432. And that was the same for iodine. They started up with the same concentration. And for product, we have 0.00703. So that's I. C was change. We determined this by comparing K to Q, and we found out that the reaction proceeds towards reactants, meaning more reactants are going to be formed. So this value is going to increase by plus X. This is going to increase by plus X as well. And our product is going to decrease by negative 2x. I told you that it would increase or decrease by nx. For the reactants, the coefficient was 1, so you could just write x. For the product, however, we have 2 hydrogen iodides, so that would decrease by 2 times x. And remember, this chart should make sense when you're setting it up. If your system is proceeding to form more reactants, this value of the reactants H2 and I2 should increase by x, not decrease. So always think of that when you're setting up the table. Finally, the last step was equilibrium, E, and that was just adding I plus C. So this would simply be 0.0432 plus x. This would be the same, and this would be 0.00703 minus 2x. All we have to do now is solve for x, and we do that using the K expression. So we know that K is equal to the concentration of the products over the concentration of the reactants. Hi is squared because of the coefficient. And then we have hydrogen gas and iodine. We know that K is 4.76 times 10 to the negative 4. And then we plug in the values. We had a E, which 0.00703 minus 2x squared over 0.0432 plus x twice, so we can just put it squared as well. And now to solve this is just math. If we square root each side, we're going to get rid of the squares on each, so we will get 0.0218 is equal to the same without being doubled or squared, 0.0432 plus x. And then using algebra, you will get that x is equal to 0.00301 molar. That is our x. And the final step would be adding it to the ice chart. So the concentration or equilibrium for hydrogen is equal to that of iodine, which is simply 0.0432 plus x, which is 0.0462 molar. That is our first part. Then we do the same to the product. We know that the concentration of HI at equilibrium is going to be 0.00703 minus 2 times x, which is simply 0.00101 molar. Those are the concentrations at equilibrium, and that was how you use the Rice table to determine these concentrations. Thank you for watching this video. I hope you liked it and found it useful. And if you did, please be sure to give it a like and subscribe to see more videos like this one.